Think of a single instruction as the smallest step your processor takes. On a new leaderboard, that one step ranges from a blink to a full minute. Most performance work asks how fast code can run. This project asks the opposite. How slow can you force a single instruction to go? It ranks the slowest found so far. Every entry ships the code that produced its number. An instruction's time is whatever the processor must do behind the scenes to finish it. The heavy ones pull the whole machine into the job. One instruction slows down for 3 reasons, each deeper in the machine. First, for a hard case the chip cannot handle the quick way, it runs a tiny built-in program of its own. Long division costs dozens of steps. Second, some instructions make the chip empty its fast memory back out to slow main memory. That is over 1 million steps. Third, a few leave the chip entirely, reaching out to a slow, far-away device and waiting for it to answer. That is hundreds of millions of steps. The champion reloads a big block of saved data from a slow, far-away address. A crowd of other cores floods that same path, so the timed instruction waits in line behind them all. That is how you force one instruction to 62 seconds. Only that one is timed, running under a deliberate traffic jam. You might read a minute-long instruction as a broken chip. It is not. Everyone runs on a stock, unmodified processor, working exactly as designed, just pushed to its worst case. The lesson reaches past this leaderboard. The single step you picture as one instruction is really a request to a whole machine. Its cost is how far that request has to travel.